second inventory cost application. So again, we have a store's inventory. They expect to sell 7,000 futons throughout the year. It costs $11.50 to store them for a year, so that's the storage fee. To purchase them, it costs $52. So each futon, to buy it from the manufacturer, to put in your store, it costs them $52. Alright? And then apparently there's a really high shipment fee. Futons are fairly large. There's some moving them around, and so there's a very large shipment fee. For every futon order that they place, it costs them $1,610. Now, it's more than likely you're not going to want to ship too many times. Right? Probably a few handful of times. Alright, first, the setup. Again, I do mine a little differently than the MyLab. Either way is fine. Right, this is just the way that I sort of prefer, so I think it's the easier way to sort of think it through. Right, X, though, is always the number of items per order. So in this case, X is the number of futons per shipment or order, however you want to word it, shipment or order. The domain, there's two acceptable domains. Either you ship a futon one at a time, all of them at once, or somewhere in between. That's the closed case. If you like the closed method, you can use that method. Or none up to the optimum value, but in this case we know that we're never going to ship it nothing, because you have to get at least your futons, and you're never going to ship them all at once. So this would be the open case. Either one of those domains are acceptable. 1 to 700 closed, 0 to 700 open. Alright, one of those are acceptable. Remember, there are three costs. There's the ordering or shipping cost. There's the storage cost. And there's the purchasing cost. Right, the ordering cost it's always the number of items total divided by X times the cost for a shipment. The storage cost is always X divided by 2, which X divided by 2 is your average number in storage. And your storage fee. And then the purchasing cost is your total number of items times the cost to buy them, to purchase. Alright, there's in words what it is now with actual numbers. So inventory cost, so in this case, total number of items, well, we want 7,000 futons. We're going to ship them X at a time. Each shipment cost, well, actually the shipping fee was a lot, $1,610. Alright, the average number in storage is X divided by 2, and you just have to memorize that. The storage fee was $11.50. And then each of my 7,000 microwaves, futons, cost $52 a piece. Alright, so there is my inventory cost, and then I'm going to simplify it. Right, so the first number is always going to be a really big number, so 7,000 times my 1,610 comes out 1, 2, 7, and 4 zeros. This should be a much smaller number, and it comes to 5.75x, and then the last number is usually fairly large as well. Ordering, shipping fee. It's the storage fee is usually the cheapest. Purchasing and ordering is usually more expensive. Alright, so there's my inventory cost, and then we use calculus to determine yada yada yada, same thing. So use calculus to figure out how many you need to ship, how many shipments you place per year, and so on. And so this means I need to find my critical values, which means find my derivative and set it equal to 0. And so the derivative is always the same way for these. My first step is always move this x up and make it a -1. So I get a really big negative number. I get that -11270000 x to the -2, plus my small number from my storage fee. Purchasing zeros out. Set it equal to 0 and solve. And so you're always going to get a big negative number, x raised to the -2, plus a small number, and that's what you set equal to 0. And then you solve. So I'm going to move this over. When I move it over, I'm going to rewrite it. So I'm adding it to the other side. So it becomes a positive, really big number. And then I'm going to rewrite it, divide by x squared. So then I multiply by my x squared. So I get x squared equals 5.75, that really, really big number. Divide by my 5.75. I'm running out of room. So I get x squared equals whatever that really big number divided by my 5.75 is. It's still a really big number. And then you take the square root, which again, usually we do plus minus. Try to write that down right. Missed the 0. Should be 4 zeros. 1960000, 4 zeros. And then the square root of that, again, we only want the positive because of photons, we can't have negative photons. And it comes out 1,400. Alright, so there would be my optimum value. Alright, so my answers, my x values, so we'd want to have the number of photons per order. We want 1,400 photons per order. Number of orders, well, the number of orders, you take your total, 7,000. We're going to ship 1,400 at a time, and so that comes out 5. And so we're going to place 5 orders per year. All right, so 5 times a year, we're going to order 1,400 photons, right, which means we'll have a total of 700. And that will minimize the ordering fee and the shipping fee. Right, and then verification. Alright, so number placed per order, number of orders placed per year. Last step to verify. So the verification's up to you. It depends on whether you use the closed or the open domain. And since I did the open domain in the first example, I'll do the closed domain in my second example. But you can do either one. Oh, there's mine. I wondered where that was. Alright. You can do either one, but since I did the second derivative test, the open case in my first example and the second example, I will do the closed case. Alright, so I'm going to use the closed domain, which means I need to find my inventory cost at 1, my inventory cost at 7,000, and my inventory cost at my optimum value, should be my optimum value, 1,400. Alright, so when I plug 1 in, it's a really big number, 6345005. When I plug 7, it's not as, actually this one's not super big. And so this is the minimum value. Actually, shipping them all at once isn't too bad because we have very few shipments, right? We're only shipping them 5 at a time. So it should make sense that shipping all at once is not going to be that much different than shipping them a little bit at a time. But this is my minimum. All right, it does save me about $100,000, a little less than $100,000 to do that. All right, so there is the second example of inventory cost, which, like I said, the MyLab does it a little differently, and it's fine. You can use either method you want. All of them are acceptable methods. You pick one that makes the most sense to you, the one that you're going to memorize, and use that for the tests and the quizzes. All right, we'll stop there.